Sí, sí. Sí, porque es que, a ver, cualquier otra cosa al final se va comiendo tiempo y es un lío. Yo puedo probar a ver si esto funciona. Puedo probar mientras. Yo por eso, si tú no tienes inconveniente, lo más fácil, ¿no? Perdona que no te da demasiado caso, pero es que estoy un poco... estamos pillados con esto y no... No, I'm going to find... I'm trying to find where the... Yeah, I do. Uh-huh. No, what I want to disconnect is the screensaver. Is the screensaver? No, I'm just, I was just trying to configure the screensaver. I will start the... So, have you started with the... Yeah, I'm here. No, don't worry. Take it easy, thank you.
Starting now. Hello, everybody. It's starting now.
You have to use the mic; it's much more effective. Those of you who are close to the doors, would you mind to close the doors, please? Robert, Rafael, would you mind to close the doors? Thank you. Well, that's for you who are not aware of it. This is the first session of Nfvrg. Welcome. And if you don't know what this is about, this is not your room, I would say. Let's start. We have a very packed agenda. Let's start. This is the notice, the IPR policy. It's not a note well because we are not in an IETF meeting. This is a meeting of the research group, but please note that we follow the same IPR policies that the IETF follows. Well, just a very short introduction on the administrivia. You have most of today's and tomorrow's slides on that URL, though we are still making a final adaptation of some of the tomorrow slides. So wait till tomorrow to be sure. Today's are stable. So it's at the first, if I remember, was the first 5 slide decks. I have not seen, I don't see anyone, well, no, I have 5 people participating in Miteco, that's good. And precisely for that, well, and apart from that, you have the mailing list information and the usual web and wiki, nothing new. And since we have a note taker who's there, thank you. No, I put your name just so you could not escape. We would need at least one JavaScript. Let me say it's a very easy task. The only thing you have to do is to connect to that Java room, and in case there is some comment or question from the people that is remotely connecting, just bring it to the mic. Anyone? You will get some stickers that will prove that you are so nice. We need just one. Come on, you don't tell me you are never connected to Java. Oh. Well, we're going 1, going 2. Okay, I would try, but the problem is that I have my, well, no, I can't even try. I mean, in the worst case, I can't even try to act as a JavaScript. I will, but anyway, I have the intention. What is this doing? I have the intention to note this in the minutes that this is you are not a very collaborative community. No. And anyway, the we'll try to do it. Well, we're going to use my laptop for the slides. I will try to take care of the Java once I make the presentation, because according to our schedule, I'm going the first one speaking. Anyway, just in the previous meetings, we have had some set of announcements on ongoing research events related to Nfvrg, but the problem is that, well, we had too many of them. It's sort of that the slide would have become completely clutched by the number, well, it would be not accurate, and it would not be useful or whatever. So the idea is that we will refrain from doing so in the coming here and in the coming meetings. But but for sure, you're welcome to distribute any call for papers or whatever, which is related to research events. And let me insist on this, because, for example, what is not acceptable and will be stopped by the chairs is, for example, if you call for any kind of commercial event, tool availability, whatever. We're talking about research events, research conferences, special issues on scientific publications, etc. Please be careful about that. The RG list is not for commercial announcements of any kind, events, products, whatever. Okay, so finally, this is the agenda for this first session. Apart from this welcome that is about to finish, and the question whether you have any concern about this part of the agenda, we will dedicate approximately 55 minutes in total to an introduce to the open source manual project that I do myself. Then we will have Felipe talking about their experience with which kind of virtualization technology, the performance of different kind of virtualization technologies. Then we'll have Dave talking on high performance service chaining, and finally Ranky will make a short announcement about this PPA project that I don't know if you know about it, but you will know. So if you allow me, we will start with the ONOSM presentation. Let me move it here. Yeah, yes, if you don't mind to make the usual. Sure. Next one, just this one. Okay, so we have. Okay, now I'm acting as presenter, so it's a continuum. So it's about introducing this project that is open source manual, OSM, that is essentially consists of the building an open source community around some seed projects that were originated. One of them is our open manual framework that we were presenting through the IETFs before in Dallas, if I remember well. Next one, please. So the idea basically is, well, is that the list you have right there. First is working on a manual stack that is first open source, and second, and very important, that is aligned with the information and data models agreed by the ETC, not necessarily with all the functional decomposition, and we will see later on what we're talking about. And that is committed to apply these models in in real operation and provide feedback to the Etsy NFV community in the, of this application. Very much focused on something that you know has been one of the of our main goals, is precisely assuring a predictable performance. When you make a deployment on a virtual infrastructure, being sure that the network functions behave according to a stable and predictable performance, not necessarily the highest possible, but predictable. And well, as you can imagine, enabling an ecosystem of solutions that are based in this model-based approach. So we avoid problems that we were foreseeing from the beginning, that on the integration, on the customers, the operators willing to make the deployments, or the required integration on the particular Mano dialects that will happen in the future. Next one, please. So it's an open source community that at the end was hosted by Etsy. It's hosted by Etsy as part of their strong commitment with NFV, etc., and that provides us with a very easy and natural alignment with the NFV ISG inside Etsy is done, with which we intend to make it driven by service provider requirements. You can see there is a list of the current participants. In fact, this is not completely updated, but because while flying here, I knew that there are a couple of other companies that have joined, but anyway, that will help you to have an idea. The ones on the top are the ones that are supposed to be driving the process. It's not that they are special in any sense that they are users of the Manu stuff. The ones that are at the bottom are supposed to be precisely the supporters of the and well, it's open to whoever who wants to either join formally the community or, as usual, contribute a piece of software, contribute ideas, contribute experiences of using the platform. This one, please. So the essential requirements, apart from providing an orchestration support, etc., and addressing the functions of a Manu stack inside the NFV environment, are these four. One is the capability of using enhanced performance awareness. So the idea is that when you make a deployment, you don't make a deployment in, let's say, the vanilla cloud style of here you are, cloud orchestrator, do whatever you want to with my functions because I cannot care less. It's about, hey, I need certain, I want to be sure that the performance is going to be between this range, so I want to know where I am, or where the orchestrator is going to deploy my function and in which conditions, and apply these conditions to guarantee a certain performance. Second, looking at what is our real experience and the diversity of organizations like Telefonica, I cannot speak from the rest of operators in the world, but Telefonica is extremely diverse and has a very wide footprint in very diverse countries, in despite that most of them speak Spanish. But, you know, believe it or not, the differences between Argentina and Spain are huge. And the differences between Argentina and Chile, being neighbors, are even larger. So that requires that, for example, these two multi-things. One is that about being multi-theme. It's difficult to mandate you are going to use OpenStack and only OpenStack and a particular version of OpenStack in all over our footprint. Well, that gets worse if we talk with our customers, etc. So the idea is precisely to be able to cover a wide variety of different VIMs and multi-site by definition. The idea is that it will work from the beginning in a single OSM instance will work with several sites from the beginning, and with the idea of rethinking the architecture and identifying two main blocks dealing on the one side with what we call service orchestration and what we call resource orchestration. Next one, please. We have decided, and as I said at the beginning, we didn't start from scratch. We are not rewriting the whole thing again. because several of the project partners have pieces of code that they were willing to contribute and to adapt and to integrate into the first release of OSM. So we have, as a resource orchestrator, we have the lovely OpenManu. We have Juju terms to manage precisely VNF, to manage the VNF modeling and for doing VNF configuration. And we have a Ritual Launchpad for service orchestration and whatever is related to DNS management. This is, well, it has some advantages, among other things, that before the formal start of the project, we were able to demonstrate some results already of what we wanted to achieve. And well, we are in the position of showing by example in which direction, before doing diagrams or whatever, we have running code to show in which direction we want to move the project. But they are only an initial starting point. The idea is that all the components will be, well, the components that we're thinking about, a service orchestrator, a resource orchestrator, and a part that is in charge of VNF configuration will be pluggable and exchangeable by others that are willing to contribute. Next one, please. The basic concepts, and this is very important because don't expect that from now on we will be talking about NFVO, VNFM, or whatever. We're talking about what we want to achieve functionally, which is resource orchestration, which is deciding how the resources are going to be organized in order to achieve a certain VNF, or well, a certain network services, a certain network service that is running totally or partially on top of VNFs. Service orchestration, that is precisely how you perform the configuration and how you attach the network functions to your network and how you put all in place for the service to be used by your customers. And, well, it's driven by these potential sources, mostly by the operators, by the VNFs themselves, or the management around that, or by the infrastructure because of whatever requirements or information that is available from the infrastructure. And for sure, service orchestration is able to make requests to resource orchestration because the service is the goal, not the resource itself. And, well, when it comes to life cycle management, when we talk about life cycle management, about what happens with something, you need to do something with the status of a certain component there that has been virtualized. We believe that all life cycle management, at the end, is affecting the service and has to be dealt with a service view. Doesn't make that much sense, thinking in our view, and this is something that we can discuss, doesn't make that much sense to say, no, I have a virtual machine that has to scale. Come on, you don't have to scale the virtual machine. You have to scale up the service. The goal is the service, not the virtual machine. You have to inform the service that you're doing something in the virtual machine because that will affect the internal function. It will affect the attachment points. It will affect at the end how you are interacting with outside of the service. So all these decisions is something that we want to be taking at the service level. Next one, please. So that implies that we are trying to change a little bit the mappings. First of all is that OSM is going to consider the GRI part there in the diagram. So we want to go a little bit beyond the pure NFVO limits because otherwise we don't have complete service visibility on the one hand. And on the other hand is that precisely the idea is that if you look at how it's structured, resource orchestration and lifecycle management are now split in two parts, and the idea is to make an evolution of this into moving this. So what you achieve is that you can think that, well, the NFVO has a part which has to deal with lifecycle management as the VNFM, but you have resource orchestration in both parts. Why not unify them in a single functional component? For sure, it's true that implies that you won't have, if you're using OSM, you won't have something that you can call this is the NFVO, I can plug it and plug in something different. But let me insist, we are trying to achieve fully functional environment that is much more focused on function and not necessarily on architecture. Next one, please. And again, it's a model-driven approach. This is something that probably you have heard several times about when talking about things like ODL, but essentially it's the idea that you keep consistently using the same models for development, for testing, and for final deployments, and and service provisioning, and that implies that you can support these so fashionable things like DevOps and continuous integration, and we are strongly committed to contribute back to IETF. Next one, please. I'm trying to accelerate a little bit. This is a list of the challenges we see. There are these several slides on this. One is when you talk about the resource orchestration, what is very important, at least for me, is that when it's mentioned horizontal virtualization. During a couple of days here, we have heard about that we have to think about what are the characteristics of a virtual firewall, a virtual router, a virtual switch. Well, I would say that we should not be thinking any longer on that. We should be thinking on which are the functions that we can virtualize. And the functions is a forwarding plane, a filtering engine, a policy enforcer, whatever. That are not the boxes we're used to think. We're talking about functions and about building services by combining those functions that are not, right now, let me insist, the nodes. Current nodes have several functions. The idea is to decompose those functions and allow a horizontal integration. And this is, in my view, this is one of the essential challenges that we have when we want to have to support that new decomposition. Next one, please. When it comes to from the service orchestration, is precisely what is very important is the first one. It's about this coherent end-to-end view at the network service level, maintaining it at all the levels, independently of the orchestration, the lifecycle events, etc. And the idea that you are able to seamless manage multi-tenancy, because in a certain service, you can have a combination of functions that are used by more than one tenant because of efficiency and performance, and network functions that are assigned to a tenant, and you have to have a proper identity management and security and isolation principles there that has to be enforced by the service orchestrator. Next one, please. For the models, well, the first is about addressing realistic NFV environments. It's not about let's make another MME that is virtualized and let's show that here is the MME, but isolated. It's about going for full services, including what we call the network scenarios, that are the combination of the parameters that are associated with the VNFs. And something that is very important when it comes to the VM, etc., is about the layer 2 topology. When you make the deployment, there are certain effects that happen with current cloud managements that you can simply not afford. Next one, please. For the VM is essentially about support on EPA that we currently fully support in OpenMano, and is partially supported in other VMs, like for example OpenStack, and we are strongly committed to go and try to contribute and to make OpenStack evolve in that direction on the one hand, and the second is facilitating a direct integration with OPNFV, so we are part of the ecosystem there. Next one, please. So, and this is just to finish. We ran a demo at the recent Mobile World Congress in Barcelona this February. It's using, I'll tell you, it's using a very realistic scenario of a VPN using VoLTE for an enterprise environment. It is completely automated. It runs using this RiveTO Launchpad interface. It tries to prove essentially the main concepts that are behind OSM when it comes to full end-to-end service automation, support for APA, the capability of being multi-site or multi-MIM, and the combination of the different VNFs depending on their performance and the requirements. And already, well, it has helped us a lot in identifying limitations and potential evolutions. Next one, that I guess is the last. Well, these are, you have there the couple of videos on the how, on the left-hand side, what the demo was about. On the right-hand side, if you are more curious and you have time, enough time, more detail about how the demo infrastructure was built, etc. I won't show anything, don't panic about that today, but if you're curious, you want to have a look, I will be more than happy to try to address any question you have while here, while you're back home, whatever. Next one, and it's just the last one, please. This is simply, last one. Yeah, this is simply just to remember if you are interested in have a look at what we are doing, how we are planning to do it, and you want to join the party, is there. And I'm done.
We have time for like one question.
One question, okay, perfect. If there is one.
Robert, go first.
I could imagine, yes.
Robert Sabo Eriksson. I wonder if you considered hierarchies of the service orchestration, resource orchestration in the context. You mentioned multiple sites and multiple VIMs. So what is your view on this?
In the current version, no. The current version is has a resource orchestrator and a service orchestrator. Sorry, yes, resource and service. For future versions, is in the let's say in the roadmap or in the plan to go. Yes, it will be considered. Not in this demo, you won't see this definitely.
I think
Up to the chair.
Okay. Thank you, and also reminder on the blue sheets in case you haven't signed. Please do sign them. Thank you.
So next one is right?
Yeah.
So it's
Right next.
no. Yeah. Document here.
Okay, thanks. Good afternoon. My name is Felipe Wisi. I'll be talking for the next 20 minutes or so about some experiences we've had while doing performance tests with different virtualization technologies ranging from VMs, unikernels, tiny distributions of general purpose OSs and containers. Next, please. Okay, so in the beginning, the VM king was on charge of everything, and everything was good. That was the only game in town. And then what happened was we got a couple of more options around virtualization for running VNFs and for other things as well. One of them is what people are calling Linux tinification. It's basically taking sort of stripped down kernels and distributions and building VMs around those. Click, please. Along with that, we have something called unikernels, which are specialized VMs on top of basically minimalistic OSs, so not general purpose OSs like Linux or FreeBSD, but sort of minimalistic ones and basically single application VMs. And I will explain what these are in more detail later on. Click. And of course, containers. And so what happens is that the VM king is not happy anymore. He's not the only game in town anymore. But click. The question is, where are we in terms of performance? And performance can mean very many different things. So we took a number of different metrics. One of them is how big is the virtual machine image size, because it matters in terms of shipping it out and then lifecycle management. Memory consumption, of course. We have things like VM creation time, destruction time, migration times. We have delay, which is important certainly for NFV. And we have, of course, throughput. Next. Okay, so we have a sort of line that sort of stretches between higher overhead and lower overhead. Click, we probably have the standard VM towards the sort of higher overhead range of things. And then we have these tinified VMs, which are probably have lower overhead. And then we have these specialized VMs called unikernels. And then all the way on the right, we have containers, right? But the question is, you know, probably this is the order. But how far right or how far left are they? Next. Right, so it could be that unikernels are actually close to containers or not. Click. Or it could be that unikernels for some metrics are ahead of containers or not. So the question is, can we actually quantify some of this? So I already mentioned the metrics. I can give you a little bit, say a little bit about the methodology. So for VM image and memory consumption, we use standard tools like ls, top. If we're on Zen, we use Excel. For the VM creation time, what we do is we create the VM and then we do a SYN flood and then we measure when we get a reset for the, we do reset detection basically. For throughput, we use iPerf and modifies versions of iPerf because iPerf will run on a Linux VM okay, it'll run on containers okay, but if you're running on a minimalistic OS, that's not the same API as Linux, for instance, so you need to slightly modify iPerf to run on those. For RTT, we just do a ping flood. All of the VM tests are run both on Zen and KVM, and we use a fairly standard, not so expensive x86 server.
Oh, I did not have to.
No problem. We'll get there eventually. Okay. So as I said, on that timeline, we had sort of 4 points. We have standard VMs. For this, we used a Debian-based Linux VM. We have these tinified VMs. We use something called Tynix, which is essentially a sort of stripped down Linux kernel and a very small distro, which is essentially BusyBox and iPerf and nothing more. And I'll give you more details about that. For unikernels on Zen, we use MiniOS as the minimalistic OS, and we put something called MiniPerf on top, which is modified iPerf, basically. And for KVM, we use OSV as the minimalistic OS, and then iPerf. Containers is Docker. Click. So now I'll speak a little bit more about, so of course, containers you're aware of, standard VMs you're aware of, maybe these tinified VMs and unikernels are a little bit more complicated, so I'll say a few things about this. First, tinified VMs. Okay, so a standard VM is an application on top of a distro. You have a lot of stuff, different layers at the kernel, services, libraries. You have a lot of elements. Click. But ultimately, you only use a few of them. In this case, if you want to run Nginx, there's only a few libraries you use, only a few kernel modules you use, and the rest is sort of just there idle. Click. So the idea under, and this is not our idea, there's a lot of people working on what they call Linux tinification, especially from the embedded world, is to sort of take only, try to build the smallest distros and kernels possible while still keeping the Linux API, because then you have compatibility with applications. Yep. And so what we call Tynix is a tailor-made distribution. And this is an example with Nginx, but we used one with iPerf, of course. Click. And just to give you an idea, this is what the PS command looks on Tynix. It looks busy, but actually, click. Most of those are just kernel threads and processes, and click again. It's only the bottom part that's the user space stuff. And if you look, you have 4 Nginx threads. You have an SSH server so that we can log in for convenience, and then you have a shell and nothing more, right? So there's really nothing much running on there. Okay, click, and click again, please. Okay, click. So that was the tinified VM. Unikernels. Go ahead, please. Once more. Okay, so what's a unikernel? It's a specialized VM. So it's normally a single application plus a minimalistic OS. These minimalistic OSs generally have a single address space, a cooperative scheduler, so there's very few overheads, there's no context switches, no preemption, things like that. So, and of course, you know, there's no extraneous code. Click. So in a picture, if you have a standard VM, you have kernel space, you have a bunch of drivers, you have user space with a ton of applications on top. Click. And then in a unikernel, you just have a single application, just a few drivers, and a single memory address space. Okay, so what about what we used? So to do benchmarking, we built a unikernel that has just iPerf on top of it. So on Zen, click please, the application is iPerf, and it sits on top of MiniOS, and on KVM, we have iPerf and then OSV at the bottom. And OSV is just a open source minimalistic OS for not only for KVM, but originally for KVM. Yep. Okay, you should know that there are quite a few optimizations to Zen and KVM when we run our small VMs and unikernels. I don't have time to go over those, whereas the container numbers are just off-the-shelf container numbers. We haven't gotten around to optimizing those. Okay. So some of the results. The first one, image size. So how big are they? These are the blue bars. So you can see it's in megabytes, and then at the bottom in the x-axis you have all the different setups, right? So from left to right you have the standard VMs on Zen and KVM, you have the containers, you have unikernels on KVM and on Zen, and then you have this Tynix small VM on Zen and KVM. So the blue bars are image size, and sort of the takeaway message here is that the unikernels, 5 minutes, the unikernels on MiniOS are the smallest, but containers, and then you have things like the Tynix is still pretty small, 3.7 megs and so forth. So memory usage, you can see it's about containers, unsurprisingly, wins 3.8 megs. Unikernels are the next behind, about 8 megs. And that's, of course, because containers, a lot of the memory usage and buffer and so forth is actually in the Linux kernel. Next. Boot times, this is a log scale. We have, again, this is unoptimized containers, so it's 1.7 seconds. And then we have Tynix beating that, 400 milliseconds. The smallest ones are the unikernels on Zen, 31 milliseconds, but we can also get it down to under 10 milliseconds. Next. RTT. The containers win here, so about 4 milliseconds. Unikernels are not far behind, 5 and 9 milliseconds on Zen and KVM, and then Tynix and standard VMs. Not surprisingly, some of the standard VMs have the same timings because the kernel itself is basically the same. Next. Throughput, TX and RX. I'm just really summarizing now. We've optimized TX on Zen, so we get the highest throughput with the MiniOS on Zen. Containers are not far behind. RX is sort of the same story. Okay. So the conclusions is that basically what people repeat is VMs have really good isolation but are heavyweight, so you have to choose between either containers or VMs depending on whether you want isolation or performance. What I'm trying to suggest with these numbers is that this is a lot more nuanced. It's not such a clear winner one way or the other, depending on the metrics and depending what you mean by a VM, right? So the sort of takeaway message is, you know, if you thought this was sort of clear and easy, it's actually not. Things like unikernels and sort of tinified VMs provide you with other points in that timeline that make it so that they may be a viable alternative to containers in sort of multi-tenant deployments where isolation is a must, at least until isolation in containers catches up. And the last one, yeah, the VM King is sort of happy again. Last one, I'm not going to read through this, but this is potential contributions that we could do towards this containers draft. Thank you.
Thank you, Felipe. No, we have Dan there for a while, so please.
So when you were using Dockers, you said containers, you were probably using LXCs. Did you try to use C groups with Dockers, or you were just focused on LXCs?
It was LXC. Yeah, we didn't do that. Yeah, yeah, we haven't looked at optimizing containers because we just haven't gotten to that. So you may say this is a somewhat unfair comparison because you've optimized the heck out of Zen, KVM, and unikernels, and you've sort of taken vanilla containers. And that's a fair enough comment. You should take away orders of magnitude comparisons out of this rather than the actual numbers.
Good question. So, very good. Use them. Yeah.
For the people that are.
Yeah, sure. So very nice work. So one of the things, we have an active draft in the area of containers. Of course, we are actually right now more investigating the issues. And what you're finding is, I think the security implications is kind of one of the biggest blockers to container adoption, besides the other issues around, you know, VNF vendors moving slow and also the OS support. So what is your take on the security front? Have you done any benchmarking work there so far?
So what do you mean by benchmarking of security?
So in the sense, say, so for example, you know, VMs by nature are secure, right? When you go to the container landscape, say through C groups and all the security provision, if you add those additional security hooks, how will that impact the performance? That's what I meant. So basically, anything you add to make the container deployment more secure, then how does it start comparing on the performance?
Yeah, I don't know. I haven't, we're not security guys. We're sort of systems and performance guys. I guess it would be possible for us to benchmark different versions of containers with and without different security options, but no, we haven't done that yet. Yeah. Yeah.
Thank you.
Okay, thanks.
Okay, yes. Now we have Dave on. Let me open it. Yes, no.
All right, hi, I'm David Olson, work at Sandvine. Next slide, please. Okay, so I want to talk about performance, high performance, NFV. Just to give you a bit of background of where we're coming from is that we've actually been using, building our network appliances using commodity commercial off-the-shelf Intel processors for about 14 years now inside our appliances. We've been achieving horizontal scale using load balancing techniques and something that was kind of like a service chaining. And recently, we demonstrated 1 terabit per second in 10 rack units of commercial off-the-shelf hardware with, in conjunction with Dell and Intel. So next slide, please. I'll tell you how to get information on that later. So the way we're coming at this is we're looking at being, a transparent middle box. Think of it like a bump in the wire, possibly multiple wires in which the traffic is being routed in an asymmetrical manner. I'll talk a bit more about that later too. So some of the goals, these should be pretty not contentious, I think. We want to say, how do we really minimize latency, really get the best possible gigabits per second per watt and gigabits per second per rack unit while using commercial off-the-shelf hardware. Next, please. Okay, first of all, I'll talk about how to make a fast component. So just one of the service functions. So the good news is that for simple tasks, forwarding, counting, a lot of things, software really can keep up with line rates, with interface rates. And I know others have reported this too. I'll talk about these 4 points as to why these are important. One of them is to think about breaking your jobs down into multiple independent threads, locking those threads to physical cores where they get the whole core to themselves, connecting those threads to physical hardware where they really are closely connected to the drivers, and using software techniques of zero copy forwarding. Next, please.
My fault. No.
You're wasting my time. Yeah.
10 seconds.
Okay.
You want 10 seconds more?
Okay, so first point. When you have these multi-core processors, the newer processors all have multiple cores. We found the best way to utilize these is to have multiple independent threads that share nothing. We found that any use of semaphores between threads, even if they're not contested, are they really cut down on your memory bandwidth. So our approach is slice up the network data so that each thread can work independently on its chunk of data. So if you're an internet service provider, a natural way to slice this is to put individual subscribers' traffic on different processors and not have to have any crosstalk between these. Other approaches are just, if you don't think about subscribers, think about using IP address hashing or something like that. And when I say thread here, by the way, there's different kind of approaches you can take. One approach is, a lightweight thread in a process, or you can have independent processes, or even independent virtual machines. And there's different ways of breaking it down. Next, please. Okay, we found it, also important to assign these threads to really lock them down to the cores that they're allowed to use. So in a virtual environment, this is two things. On the host, you want to dedicate the specific hardware cores to specific virtual machines. And then within the virtual machines, you have to lock your threads to specific cores if you've given your virtual machine more than one core. And the reason for this is you get the benefit of caching, instruction caching and data caching, and also the packets, you want them to arrive in to the right core. And other thing worth pointing out is on some of these blades, for example, that have multiple CPUs on them. Not all the CPUs are connected to the hardware in exactly the same way. It's the NUMA architecture. Also, the different memory is faster on different processors. So, we found that sometimes you'll have one of the CPU sockets will be connected to the PCI bus for the interfaces, and the other one is not. So it's actually more expensive to get the traffic to the other CPU. So you may, if your application has a fast path and a control plane, you may choose to put the fast path on the one that's closer to the interfaces. Next, please. Another thing that we found very important is to use the physical function pass-through, or SRIOV. Now, I know everyone may not know what this is. Physical function pass-through, in a nutshell, is when you give the device driver, you give the actual device hardware to the virtual machine. It owns it, and it disappears from the operating system of the host. SRIOV is a technology in which the hardware take one physical interface, give it multiple MAC addresses, and the hardware sorts the packets into different queues for each of your threads, so you can attach. And so now the hardware is sorting the packets for you, and you don't need a piece of software to sit there between the physical function and the virtual machines. I think I've explained that now. Okay, thanks. So those are my tips for within one virtual machine. Now, how to scale out. So I mentioned earlier about what we call asymmetrical traffic, and the reason I'm going down this road is because some service functions, particularly transparent service functions, want to see all traffic of a flow in both directions. Think of a firewall. If it sees typically you say, I want to allow a flow in if I saw the SYN packet out, and then I'm going to allow the traffic in. If you're only seeing the incoming traffic, you can't make the right decision. Anyway, but as we know, in the internet, packets can take multiple routes. They can take multiple links. So we want to bring those together for processing. So next slide, please. So this is a typical way we put together a solution. The devices on the left, those would be your intersecting a link. So these would be like transparently, you want to make a bump in the wire view there. So the traffic coming in, say on the top one, the red path, the traffic comes to a device, and I'm showing this like a service function chaining now, where we hit a classifier, choose the virtual machine to send the traffic through. The virtual machine returns the traffic to the link it's supposed to go out. I can have another link on the bottom shown by the blue path with traffic in the opposite direction being sent to the same virtual machine because it's the same subscriber, or it's the same IP address, or it's, and we call this, you can think of it as, there's two things going on here. There's a load balancing. We're trying to make use of all the virtual machines in a fair way. And also we're consistently removing the asymmetrical traffic. Next slide, please. So something I also want to talk about is we think of the east-west bottleneck. The more virtual machine, every time the traffic goes in and out of the virtual machine onto the switch fabric, you're using up interface bandwidth. And as I mentioned earlier, because the software generally can keep up with the interface rates, you're really become bottlenecked on the bandwidth. We also point out that as you encapsulate traffic, you make the traffic bigger, and traffic that comes in on a link can't go to the, when it goes to the service function, it actually takes more bandwidth than it initially. So maybe this is kind of obvious, but if you have a two-touch solution, if your packet goes to two machines, you really need twice the gear of a one-touch solution. So you really, that's okay, I guess, for the functions themselves. But if you're adding extra components to just you know, touch the traffic to forward it, it becomes an extra cost. Okay, next please. So one of my suggestions for the service function chaining, everyone here may not be familiar with it, but there's a service function forwarder, SFF, and there's a service function. These are identified as architectural components. We think it's really a good thing to put them in the same thread. So even though they're architecturally are distinct components, we suggest putting them together. Because you know, if you have a separate software component to do the service function forwarding, you're dedicating at least a core to do the forwarding per interface. You're adding extra latency, extra queuing, and it's also, if it's on a different device, it's consuming your east-west budget. Next, please. So this is service chaining, one service chain, so you think of it as one packet, through two functions, with the service function forwarder inside the function itself. So, you know, packet can come in, be classified, choose a virtual machine. The virtual machine, because it's got the SFF function in it, 5 minutes, okay. It can be forwarded to the next virtual machine, and then it can be forwarded to the final hop. Whereas, next slide, if there's an external forwarding function, you know, it has to go to the SF to the SFF, back to the next SFF. So that function on the bottom is really, every packet's going in and out twice. And it's really chewing up a lot of interface bandwidth. Next, please. So my point about to minimize encapsulation overhead, you know, it's not really an MTU question to us, because we can control the MTU in this environment. It's a question that every time you encapsulate, you make the packet bigger. It's reducing the effective bandwidth because your packets are bigger. You know, 10 gigabits in, 10.1 gigabits come out. You may not be able to take 10 gigabits in. So in the service function, in the NSH environment, in kind of the architecture I was showing you, we would choose direct encapsulation on top of the Ethernet. So we would take the MAC, followed immediately by an NSH header, run it on the same layer 2 segment. We would resort to using an IP encapsulation only if the devices were separated by an IP network. And there are different metadata types proposed for NSH, and we would take the type 2 when we don't need the extra space for the metadata. Next, please. Okay, and then I was reflecting, I think I'm almost at the end. I was reflecting on the question that everyone asks is, you know, okay, so how many VMs do I need? And unfortunately, the answer right now is, you know, it depends. I'm trying to give you a hint from, you know, all the things I talked about. It depends on, okay, how is the application written? Were different threads used? How much memory bandwidth is used? You know, the characteristics of the application itself. What kind of technology I'm running on? Is the application written in a way that's compatible with the kind of architecture I'm running on? Does the application support the offload to the NIC in the SRIOV sense? Does your infrastructure support that? Am I able to assign cores, threads to cores? Can my virtual machines accept that configuration of which cores to run the threads on? And then, you know, the real hard part comes in thinking about the path of your packets. You know, how many interfaces do they have to go in and out to satisfy your solution? And is your switching and interfaces, are they bottlenecking your solution? So it may not just be the VM performance that's bottlenecking it. Next, please. So, zero copy packets, use your hardware acceleration, pass through SR-IOV, slice up the traffic, really think about the east-west traffic, try to minimize that, minimize number of touches, and to do that, put your forwarding decisions in the thread of the function itself, and keep the packet overhead low. I think my last slide is the next one. And I've included a link to our blog post on the terabit per second performance. It's it's marketing material, but it does have a lot of details in all the different, exactly what hardware we used and how we assigned functions to cores and how we wired up and all the different parts we purchased and put together for the demonstration. And some of this is also discussed in a draft in the SFC section, but that's just something I contributed recently. Do we have any questions?
Thank you. Open the questions. If you may ask before he's getting onto the mic. So essentially, what you're proposing is, the SFF being absorbed with the service function. That means if you need overlays, then that is happening right there as part of the service function itself. You're instantiating overlay. Is that a fair assumption?
I don't know if it's an overlay. It's the same.
No, essentially, it depends on the deployment, right? You're doing SFF, the service chaining function, but if you need an overlay, then do you consider that happening separately, or it's still part of what you're doing?
Yeah, I didn't think about that, but yeah, I think you could think about overlays there as well. So if you can remove, an extra thread, its only job is to say encapsulate and do a next hop, I think that's a good performance choice. Now it may become more, maybe you may want to trade that off for other objectives, but from a purely performance point of view, I think that's my point.
If overlays deployments are there everywhere, and if that doesn't, if you don't gel those together, then you don't get the best of it. Yeah. Sure. So what I meant was,
Move. Oh, you unplugged it. Okay.
So what I meant was essentially, from what you're seeing, unless overlays are combined with such an idea, it doesn't get the full deployment benefit. That's all. And overlays are there anywhere, everywhere.
I see what you mean. Yeah. So cool.
Thank you.
Just in case anyone else wanted to make a question, we are closing the line. So, Felipe, please.
Okay, I'll try to be quick. So the first one is a clarification question.
If you don't mind to identify yourself.
I thought you had identified.
No. It's let's just say that you are Felipe Wisi.
Yeah, Felipe Wisi. First, a very quick clarification question. Is it KVM and Open vSwitch? What are you using as the technologies?
Yes, I believe it's KVM. Yeah.
Okay. And the second one is we've been doing performance optimization for NFV for a while and performance measurements. So a lot of the things you touched upon are certainly tricky. Another one that's even worse is that a lot of the NFV functions are dependent, how expensive they are is completely dependent on the traffic matrix and what's actually in the traffic. I'm thinking DPIs and things like that. How do you cope with those?
Yeah, I think we talk about that in our report. I think we did we call the internet traffic mix, which is kind of a sampling of all different types of traffic together. So
okay, and what's the
second? I agree with you that it does. That's probably something else I should have put in my it depends slide. Is the type of traffic that you're looking at.
Okay.
This is the kind of thing of discussion I would love to see in the list, please. This is if you have some particular patterns to validate this, and this is the kind of thing that would help us in making evolve this and make a real contribution. Now, I'm sorry, but this should be.
Dan Bogdanovic. More and more, especially data center operators, are complaining about the power consumption and the heat dissipation. When you're looking into the performance, are you looking in any of those? What is the power cost per bit, and the heat dissipation cost per bit? Because this is also those thermodynamics are giving them more and more headache.
Yeah, as our this is one of my second criteria. If you go to a report, you can get the exact numbers that we talked about. We talk about watts per gigabit or gigabits per watt. I can't remember which it was. We found it just a little bit more than our appliance, and you can anyway see some comparisons we made.
Okay, thank you, Dave. The last one should be very quick because Ranky asked it explicitly to make it very short. So here you go.
Yeah, just go to the next slide, please, straight away. Yeah, thank you. So when you started off Nfvrg, one of the key goals was, not just drafts and ideas, but how do you influence real implementations happening? And with that, we wanted to make a direct impact on the most relevant open source projects, which include OpenStack, OpenDaylight, and OPNFV. And with that, essentially what we did was we saw that the policy-based resource management work item has had the maximum interest in the community. I think 10 plus, in fact, close to 15 drafts. And in fact, specifically on the resource management tying it to policy is something we've been working with the Nfvrg team and also the OpenStack community for almost last 4 months, refining a proposal. And the output of it is, I'd like to call as a policy-driven platform-aware scheduler. Essentially, if you look at the OpenStack scheduling framework, and several presenters talk about the need for platform awareness. Diego talked about it. Dave talked about it. Basically, SRAOV, all those, hardware acceleration. How do you bring them on board? So some of the key problems we see with the current OpenStack scheduling framework are that the framework is not extensible. If you want to add a new feature, you have to wait 6 months, right? Basically, next OpenStack release. And also, when it comes to usability and in terms of, whether you made the right placement decision, how you actually verify whether things happen, even there is a gap. And also the other big problem we see is lack of a single representation for monitoring and placement. That means essentially, when resource utilization changes, you want to go verify and see whether, this should be the right placement or it should be something else. So these are some of the key areas we're addressing to the spec. And I think the best part about this is essentially the feature velocity. That means this is headed in the DevOps direction. And essentially being able to introduce new features, at DevOps pace in the order of weeks and not wait for an OpenStack release. And there is a detailed spec which is under review. Basically, you have to follow the OpenStack community process, which is pretty intense. And it's kind of somewhere between use cases and also a strong developer influence based on the current code base and what can be done and cannot be done. And we'll have a big presentation at the upcoming OpenStack Summit where we'll not just talk about the use cases, the current problems faced, and also the architecture, and perhaps some implementation details. And last but not least, I would like to say that the goal of this is not just producing, but also who's going to be the consumer. That will be OSM, and Tacker, OpenStack Tacker, which is another OpenStack orchestration project, or AT&T Ecom. It can be anything, because the way we are defining the northbound APIs is through OpenStack Heat template, and we're not changing that consumption model. It can be easily consumed. So that's all I had.
Okay, so it's about time that we have to leave. Just to remind you that tomorrow there will be a much more exciting and longer session in which we will discuss drafts, etc. It's at 2, right? From 2 to 4. See you tomorrow. Who has the blue sheets?